So an 8800 megahertz transmitter is moving directly away from a receiver at 291 knots. You're asked to find out the speed of relative motion in meters per second, frequency shift at receiver in kilohertz, and frequency received in megahertz. Yes, I'll give you some time.
Yeah, so for that reason, that 291 knots directly converted to meters per second will be the alpha, speed of relative motion.
Exactly, correct. So since the transmitter, the transmitter is moving away from the receiver, let's draw the receiver on the ground, and say for example we have the transmitter in the aircraft. The transmitter is moving away from the receiver at 291 knots. The velocity of the receiver is 0, and for that reason any relative velocity will be basically velocity of the transmitter, and velocity of the transmitter is 291 knots, and therefore relative velocity is 291 knots. You're asked to find out relative velocity in not knots, it's in meters per second. We have to convert this to meters per second. So it's almost going to be half.
150.
Yes.
149.70 this time.
149.7?
Yes.
Yeah, so you can take it as 150. Look at the options and you can always round off to 150 meters per second. Perfect. Yes. And the next one is asked to find out frequency shift at the receiver. So the transmitter, the aircraft is transmitting something towards the receiver, and the transmission frequency is 8800 megahertz. So what is the frequency shift at receiver in kilohertz? You can use the basic equation. Relative velocity divided by speed of light is equal to frequency shift divided by frequency of transmission. Relative velocity is simply equal to velocity of the transmitter, which is 291. You have to find out the Doppler shift frequency, which is relative velocity of this to 150. I'm taking it in meters per second just to keep the unit same. Into frequency of transmission is how much? 8800.
Yeah. So 4.4 kilohertz.
Okay. Divided by speed of light, meters per second. Yes. What is the answer?
4.4 kilohertz.
That's right, 4.4 kilohertz. You get 4,400 hertz. We have to find out it in kilohertz, therefore that is 4.4 kilohertz. And the third one, Charlie, you have to find frequency received in megahertz. So what is the frequency received in megahertz? If the frequency of transmission is 8800 megahertz and the aircraft is moving away from the station with a frequency shift of 4.4 kilohertz. So here the receiver moving away. Sorry, the transmitter moving away from the receiver. Frequency shift is
8799 megahertz.
That's right. So the observed frequencies, what the received frequency at the receiver down here will be the transmission frequency, which is 8800 megahertz, plus the and the shift frequency is 4.4 kilohertz. And since the transmitter is moving away from the receiver, there is a drop in the received frequency by a small amount. So you can see that when you tune into a particular navigation aid, the frequency experience is actually changing by this with respect to velocity, but it's changing by such a small amount that as far as we are concerned, practically for navigation not a concern. But you can use the small change to find out the downspeed and drift if required. So you can actually find out the actual value. It's going to be like 8800 or 8799 point something.
8799 megahertz.
Right? Yeah. So how much is it?
8799 megahertz.
So 8800 megahertz minus 4.4 kilohertz is 4.4 into 10 to the power minus 3 megahertz, and therefore that is 8800 megahertz minus
0.00.
Yeah. Now if you subtract this, what is the answer? 8,799.
Megahertz. And some big values are there.
8799 does
8799995600.
06 megahertz. Yes, but that's actually almost very close to 8,800 megahertz.